So my name's Ellis. I head up the specification team here at Recoup. The presentation today is wastewater heat recovery for residential new build. It's a bit of a whistle-stop tour really through wastewater heat recovery, an overview on how it's used and how it impacts the new Part L regs, and then a bit of a design-in overview, a little look at SAP for the SAP modelers in the room, and then hopefully a case study at the end, and then some time for questions and answers. I do have some strategically placed pause slides between each section, just so that if there are any questions, we can make sure that everybody's fully understood on the section we've just been through. I do have my colleagues James and Craig in the background, so please feel free to ask questions in the chat if you've got questions as we're going through, and we can certainly answer them either as we go if they're relevant to the section, or at the end if for those that towards the end there. And yeah, hopefully we will cover everything. It's quite a lot of content here, so I will go through at probably a fair pace, but I'll share the content, the slides with you afterwards, and with follow-up. And just to let you know, also this is focused on residential, but we do have another presentation which is more focused on non-residential and Part L, which we'll be introducing as an online presentation from next month. So if you're interested in that, that'll be a bit more case study led. So if you're interested in that, please sign up. We'll send a link out for that one. Okay, so hopefully we've got a few people in now, so we'll start moving forward. So as I said, introduction to wastewater heat recovery, how it works, some detail on Recoup's products and the various products types and the scenarios that they work with, a look at how why wastewater heat recovery is important for future homes going forwards, and then a look at sort of designing in and the impact in SAP, and then some case study. So here we go. So who uses wastewater heat recovery? Well, at the moment in the UK, it's predominantly used by new build developers, and it's been driven by Part L regulation. So up until, as you're probably very aware, we've got new regs which are just transitioning now, so Part L 2021. And the expectation is that there will be a lot more use of wastewater heat recovery going forwards once the transition completes. But historically, used by new build developers to gain Part L compliance, not necessarily across the board for most developers, but certainly ad hoc with developments where maybe an increase in local energy efficiency uplift is required. So certainly new build housing is the main market, but we also have products that are suitable for apartments, for bungalows, for passive house, etc. And then certainly going forwards and more recently, last couple of years, a lot more interest from student and hotel accommodation new build projects. So non-residential is seeing a big uplift in the use of wastewater heat recovery. And essentially anywhere where there's showers, so anywhere with especially high shower traffic, so environments such as gyms, communal changing rooms, swimming pools, etc. And then looking forwards, the bigger market is potentially coming from housing stock upgrades and domestic retrofit. Now, as it stands in the UK, the main funded driver for retrofit is eco, and historically eco is only allowed for space heating measures, but the expectation is that this year that will be opened up to other measures, and the expectation is wastewater heat recovery will be a real low-hanging fruit there, certainly in the way that loft insulation was going forward. So we expect a bigger uplift from the more general domestic retrofit market. So why use wastewater heat recovery? Well, it offers significant energy and CO2 reduction for new build, and that's the real kicker. It's easy to incorporate within the new build scheme. There's very little little layout adaptations for existing houses if you're transitioning from one set of regs to another. It offers very simple, cost-effective Part L compliance. No one likes to think of their product as a box ticker, but the reality is this ticks that box very, very well. It installs for relatively a low amount of money, and it gives a big uplift in SAP. And importantly, it works on hot water, and there's not too many measures out there that have a big impact on hot water use. And on the subject of hot water, I mean, to qualify the impact that wastewater heat recovery can have, a pipe system installed to a new build on a primary shower, we'd expect that to reduce the amount of energy or primary energy per shower use by about 55%. So it really can be quite significant. So it's either less hot water use or more efficient produced hot water, or ideally both, and we'll go into that as we go through. And then importantly, there's no end user interaction required. So wastewater heat recovery is, for all intents and purposes, part of the plumbing infrastructure. It's a passive heat exchanger. There's no mechanical connections, no moving parts, no filters, no consumables, and so no end user interaction. So it can't be switched off, it won't be isolated, there's no filters to block up, it just works every time the shower's used. As I said earlier, it's very easy to design in. Sorry, that's a grade out there, but very easy to design in. Essentially a fit and forget product, and it has a very long working lifespan. So BAEs attribute around about a 40 to 60 year working lifespan for the vertical pipe systems, and around 25 years for the horizontal systems, as they haven't been in the market as long. But if you compare that to sort of the expected working lifespan of a boiler or an air source heat pump, for example, it really is significantly longer. And then finally, for those who are working more progressively, we have a very low embodied carbon with our product. I'll go into it with a couple of slides towards the end, but it's a very low embodied carbon because it's highly recycled and highly recyclable materials used. Just for those that have joined us a little bit later, hopefully you can see the full screen, but if you can't, just click the 3 dots at the bottom of your screen and fit to frame, and that should give you the full screen. Okay, so Recoup have a full portfolio of wastewater heat recovery products, all designed for various shower scenarios. The main products for new build housing, which is where this is focused, is the pipe hex, which is a vertical wastewater heat recovery pipe system. So initially I'll just give you an overview on how it works, and we'll focus on that pipe. So just a quick animation here to show how that works. Just wait for it to load up. So what we're looking at here, as it kicks in, is a standard arrangement with a sort of new build home with a first floor shower. And what you'll notice is that the pipe is located on the floor below the shower, because it's, in most cases, wastewater heat recovery is gravity fed, so it needs to install lower than the shower that it's attached to. Now, when you shower normally without wastewater heat recovery, with a thermostatic mixer, that comfortable sort of 40-41 degrees that you're getting out the shower head is produced by around about 50% generated hot water, about 55-60 degrees, and around about 50% incoming cold water main at around about 10 or 12 degrees. And that 50-50 mix at the shower mixer gives that comfortable 40-41 degrees. Now, of that, around about 85 to 90% of the heat energy normally goes down the drain and is lost out the building. So it's a big waste of energy, and there's certainly a lot of energy that's locked up in that wastewater that we can utilize, and that's exactly what wastewater heat recovery does. So what we do, we put a heat exchanger, in this case the pipe system, on the outgoing waste. So as you can see here, we've got the shower waste running through one side of the exchanger, and then on the other side, as the shower's switched on, warm waste goes down one side, cold water main is drawn through the wastewater heat recovery unit, and that is preheated. So in the example we're showing here at standard shower rates, that cold water main coming in at about 10 or 12 degrees would normally expect to be preheated up to about 25 to 28 degrees. So it's a big free energy uplift of around 15 to 18 degrees. And that's the basic premise of wastewater heat recovery, all products, all types. From there, however, there are 3 SAP listed installation methods that are recognised for SAP modelling and for new build. They're called System A, System B, System C. So what we're showing here is System A, and I'll just move over to a static slide because that shows it a little bit easier. So System A is the most efficient method of piping up the wastewater heat recovery. And as you can see here, cold water main going in, coming out preheated, and then what we're doing, we're sending that preheat to the cold side of the shower mixer. So what will happen is the shower mixer will automatically adjust the ratio of hot to cold in favour of more free issue cold and less generated hot water to about a 70-30 ratio in most cases. So immediately you're using less hot water per shower use, but also by sending the preheat to the hot water source, the hot water source doesn't have to work as hard to heat from normally 10 or 12 degrees up to 60. It's now working to heat from 25, 28 up to 60 degrees. So we're using less hot water per shower, and the hot water you are using is produced more efficiently. Now, what I'll say at this point is, because this is focused on new build regulation, and the assumption is that in the main that will still be under gas boilers. So we'll focus mainly on wastewater heat recovery and gas boilers here. But wastewater heat recovery is essentially technology agnostic in terms of the hot water generator. So it could be an air source heat pump, it could be a heat interface unit, solar thermal, microwave boiler, electric immersion heating, whatever your hot water source is, as long as there is a thermostatic mixer shower and a hot and a cold feed to that shower, wastewater heat recovery should work. And certainly in domestic, it's pretty standard, but on non-domestic, we can certainly work with you if you're looking at projects that way. So that's System A, that's the most efficient method. System A is also the method that we would normally suggest for your primary shower because it's most efficient. So in a new build home, primary shower installed as wastewater heat recovery installed as System A. Any secondary systems would normally be installed as System B. So System B, as you can see here, is where we simply send the preheat just to the cold side of the shower. So this is simply adjusting that ratio of hot to cold. So we're using less hot water per shower use. It's the least efficient method of installation, although that's still significant. We'll look at that in a moment. But it is a very simple method of installation. And if you can imagine, if you were installing this into a second ensuite, for example, you would probably send this cold feed would probably be teed off from the shower above, or so from the shower room above, and simply drop down into the wastewater heat recovery unit and then up and then onto the thermostatic mixer. So it means that the System B installation is completely closed loop from the hot water system. So certainly used for secondary showers, but also the dominant way of installing into non-residential as well. And then just for completeness, as I'm sure you'll guessed, System C sits in between, and this is where we send the preheat just to the hot water source only. We rarely see this in non-residential, but in residential settings, you might use System C to reduce the amount of pipe work. Sorry, I thought it was... James, could you just make sure everyone's on mute, please? Sorry, System C is where we pipe to the hot water source only. You might see this in townhouse arrangements. So if, for instance, you've got a first floor shower with a stacked second floor bathroom above that, so shower or bath, both of those might feed down to a pipe located on the ground floor. And then quite often in townhouses, you may have a utility room with a combi or a cylinder in the utility room. So that would just be less pipe work just to feed straight to the utility. So that's the basics of wastewater heat recovery there, and the SAP listed installation methods. Just to focus on the impact. So wastewater heat recovery, like any heat exchanger, will give better efficiencies at lower, slower flow rates. And that's exactly the same with us. So as standard default for previous regulations, 11 litres per minute was the standard shower flow rate. Under new SAP, specifiers can specify lower flow rates, which means you get more efficiency out of wastewater heat recovery, but also reduce the amount of hot water and water being used for those showers. So it really is something to consider if you're specifying. But what you'll see here is the heat recovery efficiency of the wastewater heat recovery will increase at lower flow rates. So what we're showing here is the common flow rates, 11 litres per minute and 9 litres per minute. This is the overall efficiency of the heat recovery device, and this is the energy demand reduction on System A. So as you can see here, installed into a new build at 9 litres per minute, we'd expect around about a 58% reduction in the overall energy demand for showering. And then on the other side, on System B, as I said, the least efficient method of installation, but less pipe work, this gives around about 40 to 43% energy reduction. And this is a pure hot water, using less hot water per shower. So has secondary benefits as well in terms of reducing plant size and things on bigger projects. So, sorry, where are we? James, I'll just pause there. Any questions on that section at the moment? No, I'll take that as a good sign. Okay, we'll move on then. So just going to focus on the wastewater heat recovery products themselves. So as I said, the main product that's specified, and certainly the most specified product for new build housing is the pipe hex. This is a 2 metre, in fact a 2.1 metre vertical heat exchanger pipe. And as you can see, it's normally boxed in next to the SVP on the ground floor below the shower it connects to. Would normally install ideally within about 3 meters of the shower waste pipe. In practice, because of falls on waste pipes and things, it's quite difficult to be further away than that. So 3 meters is usual. And as you can see here, it simply boxes in. This is actually on a Barrett site, and the unit just boxes in, and in most cases the homeowner just simply wouldn't even know it's there. It's very low profile in that respect. So what you have, going here, you can see on the yellow pipe we've got a shower connected above, and the eagle-eyed amongst you might also see there's another pipe coming in here. This on this particular house type is taking the waste from the shower over bath, which was located next to this shower. We get very high efficiencies on the pipe hex. It's one of the highest efficiency products on the SAP database. In part because we use a very long heat exchanger pipe, but also we have this turbo rotator, which is used just simply to direct the flow of waste. So it rotates and has a kind of cyclonic movement, and then that allows that waste to cling to the inside of the heat exchanger pipe. It gives us what's called thin film heat exchange. So we're maximizing the surface area, maximizing the surface contact, and maximizing the heat transfer onto the other side of the heat exchanger. But also, rather than that warm water falling straight down the middle, it reduces falling water noise and things like that as well. So as you can see here, this is a standard setup. So we've got the waste coming into the turbo rotator, drops down through the wastewater heat recovery unit, and then just vents off to the SVP as normal. So we're not collecting the grey water, we're not storing or harvesting any energy. It's pure heat transfer. And as that warm waste comes down, cold water main comes in, goes around the outside of the unit and comes out preheated. So in addition to what we would supply on this unit, and this is the same for all wastewater heat recovery products, all that you need as an installer or as a specifier is an isolation valve at the bottom and best practice at the top, and a double check valve for water regulation compliance. So it really is very, very simple to install at first fix, and certainly it's ideal for house building. It requires very little changes to existing designs. So as we said, it installs next to an SVP. Normally your SVP boxing would probably be about 220 by 220, with wastewater heat recovery included, around about 200 millimeters extra in one dimension. So really is very, very little extra floor space. So yeah, doesn't take up a great deal, and certainly very easy to design into existing house types that might be transitioning to new regulations, or if you've been asked for uplift and things like that. Just to give you a cut through on the heat exchanger pipe itself. So what you can see here is this is the copper heat exchanger pipe. It's a smooth internal 50 millimeter diameter heat exchanger on the inside. So this is where the waste flows, and that literally just flows down the middle, clinging to the sides there. And then the cold water main comes between the exchanger and the PVC outer here, and that's where that picks up, turbulates and picks up all that heat energy. The eagle-eyed again amongst you will see that we have striations here, so marks within the pipe. So the construction of Recoup pipes is a mechanically pulled pipe through pipe, and those striations run the entire length of the copper heat exchanger. They are there to give us a visible leak detection system as a belts and braces approach to water regulation compliance. In practice, it means that if there was ever a situation where there was a perforation in the heat exchanger, you would at first fix get a visible leak at the bottom, so that's your visible leak detection. It means then we can directly comply with UK and European water regulations. It means that in practice that the shower trap can stay in place under the shower and doesn't have to move downstream on the wastewater heat recovery unit. So all Recoup products use a double-walled exchanger, which means you install them as you would expect and the shower trap remains in place where it should do. That's a feature of all of our products. And then just for those who are specifiers and maybe any developers on, all of Recoup wastewater heat recovery products are stocked and sold by the main national merchants. We're the only product that's stocked and sold by all the main nationals, so we dovetail very well into developer and house builder supply chains. Just a quick on installation operation, because it really is very simple. It's a bit of just a summary of what we talked about here. But first fix installation, generally around about 1 to 2 hours of extra hours of plumber's time. So really relatively quick, relatively easy. Only basic plumbing materials and tools required, so there's no specialist commissioning, no MCS accreditation or anything along those lines required. It's your jobbing plumber, your installer that can do this. As I said, no planned maintenance, just simple cleaning routine required as you would with any normal shower. So the same drain cleaners that you might use on your shower now can be used with wastewater heat recovery. It's all RAS approved materials. And as I said, no behavioural changes. So it really is important for the end user that they simply don't have any change in their showering experience. They won't even know wastewater heat recovery is there in most cases. So that's the pipe. Now the pipe is absolutely fantastic in terms of high efficiency and how cost effective it is in terms of sap points. But the negative is on anywhere where there isn't a first floor shower is it needs to locate on the floor below the shower it connects to. So for housing, absolutely fantastic, but for apartments, for ground floor showers, etc., not so much. So we have a range of horizontal wastewater heat recovery products. So the first product is the Easy Fit, and this is designed primarily as an underbath system. So it will locate in the unused void space directly under the bath. So great for apartments. This was designed mainly, initially for apartments because primarily in apartments, a thermostatic mixer shower over a bath will normally be the primary shower or bathroom in an apartment. So this is absolutely brilliant for that. So as you can see, locates directly under the bath. Same basic installation method, I'll show you that in a moment. With horizontal systems, they're not quite as efficient by their nature of design as vertical systems, but they do score very well in SAP, and I'll show you that in a moment. But as well as being able to fit under a bath, they can also fit under a suitably sized shower riser tray. So if you have riser trays from say 1400mm long onwards, the wastewater heat recovery unit the Easy Fit will fit underneath that in most cases. And as I said, works in the same basic way. We've got warm waste coming in one side of the heat exchanger, going out the other side, counterflow heat exchange, so the cold water comes in one side. In this case, we have a kind of a flat serpentine exchanger, it goes all the way through here. It's about 2mm above the base of the unit. So the way this works is the warm waste from the shower or bath will flow through the unit. It will go mix and turbulate over the exchanger, which will cause lots and lots of mixing and therefore lots of heat exchange. But also because it's 2mm, the exchanger is 2mm above the base of the pan. At the end of use, if there's any debris or hair or anything like that that's come through from the trap, and obviously the bath trap or the shower trap remains in place and does the heavy lifting, but anything that does come through will just wash straight out through the unit. So it's designed to allow debris to flow through, and unlike other product designs on the market for underbath systems, we're not focusing that waste to go through a small gap or a small hole. We allow it to flood out, and so that way we're not promoting any kind of blockages and things in there. So designed from the ground up. This is the most efficient product of its kind on the market currently, and very cost effective. Certainly in terms of SAP for apartments, the way that SAP scores and hot water is treated in apartments versus homes or houses is treated slightly differently. So the Easy Fit, despite being slightly less efficient, will score very similarly to the pipe in a house. So they score very similarly, and they're also very similarly priced. So it really is an ideal product for apartments. However, there is also a trend now for low profile shower trays in apartments, as well as for DDA environments and modular builds and things like that. So breaking with the tradition of completely passive wastewater heat recovery products, we've just now introduced an active upgrade kit which works with our existing pipe system. So what we're looking at here is a pumped system which will allow the vertical pipe to locate on the same floor as the shower it connects to. So for instance, in an apartment, it might locate in the service void behind the shower, or in a modular, it would be able to locate within the pod floor footprint and can be delivered with the pod. So really good design, this one. It adds a lot of flexibility in where wastewater heat recovery can be used, and kind of the final piece of the puzzle really for apartments and new build housing and ground floor as well. So it's a very flexible design. I mean, I'll just show you a CAD here. This shows the basics of how the wastewater heat recovery unit will work. So the warm shower waste will flow into the pump system. This is an off-the-shelf Saniflow flat pump. So we've teamed up with Saniflow here because they have fantastic servicing, fantastic warranty, and fantastic network of engineers. So this will flow into the unit, and then that will activate a flow switch. We'll pump up rapidly into our proprietary buffer tank here, which has a turbo rotator within it. That will then direct that flow of water, and it will fall through the pipe as normal. So the wastewater heat recovery system works in exactly the same way, remains passive and planned maintenance free. But obviously we are introducing here a mechanical pump system. It does have a lot of flexibility in design. So it means that in bathrooms, in podded systems, it can be designed in quite flexibly. But as I've sort of alluded to, sorry, I'll go back a slide. As I've alluded to, we are introducing a mechanical component here. So obviously the pump system, the pump unit itself does need to be accessible. So whilst the wastewater heat recovery can be installed as essentially with reasonable access, so behind the shower wall or something, the pump unit itself does need to be accessible. So we're kind of seeing this being designed into under sink vanity units and things. So that flexibility of design is really quite important in this in practice. However, this has just been SAP listed, and excuse me, going back one. And because the pump is such a low wattage system and it only works by design for about a third of the time that the shower's in use, so it's very, very low wattage, BRE have listed the pipe system without including any additional penalty for having the pump. So the pipe hex active will score exactly the same as the passive pipe in SAP modelling. So it really is a big win in terms of apartments, but also other areas, ground floor showers, etc., etc. And then just for completeness, not really used so often on residential, but we do have a range of wastewater integrated wet room drain channels. So these are used primarily for communal showering environments, but certainly anywhere where there's tiled wet rooms or vinyl wet room floors, these units can be used. They're very robust. They're absolutely fantastic for non-residential settings, as I said, changing rooms. As you can see here, all of the wastewater heat recovery element is located within the main body of the unit, and everything is completely accessible. So these are a great range of products, have efficiencies between about 35 and 57%. So again, market leading efficiencies on the highest efficiency model. A little bit more expensive, which is why they tend not to be used in residential, because we have all the other products that can be used. But certainly if you are looking at this for non-residential projects, if you've got high shower traffic environments, gyms, leisure, the ROI on these things can be incredible. So they really are something to look at. And to be honest, if you're looking at gyms, leisure, sports, it's going to be very difficult to get through Part L without wastewater heat recovery going forwards. I'll pause there just to see if there's any questions on products, James. If not, we'll sort of move on to the compliance side.
Hi, Alice. There's just one question on the potential for blockages in the heat exchanger units, but I think you've kind of covered some of that. Yeah. So so by design, obviously we're designed not to block, and certainly taking the pipe as the example, it's a 50mm internal diameter pipe, so it's actually wider in terms of diameter the most standard plumbing waste pipe is. The turbo rotator again is just an internal diameter of the pipe, so there's no mechanical parts in there. It's just used, it's a twisted pipe essentially, used just to direct the flow of waste. In terms of pedigree, I guess, is probably the easiest way. I mean, today Recoup have been in the market for new build housing since 2012. We've been sole supply to Barratt, for example, since 2013, so they've been using them for 10 plus years. We've not ever had an issue in a domestic setting where a unit, or a non-domestic actually, where a unit is blocked. Our products are designed and manufactured in Holland, which is a centre of excellence for wastewater heat recovery. They've been using it in Holland for 23 plus years now, and again we've got lots of long-term projects with long annual and sort of 10-year monitoring programs in place, and there isn't any evidence of these things blocking, or in fact of evidence of the efficiencies dropping over time as well. So they really are, all the kind of kinks in design, if you like, have been designed out realistically before they even got to the UK market. So
hopefully that gives some assurance there. It's also worth mentioning, I guess, that we give a 10-year warranty on the pipe because it's been in the market for so long, and a 5-year warranty on all other products. So why is wastewater heat recovery important? I mean, obviously we've mentioned it's saving energy, but what does that really look like? So historically, space heating has always been the biggest energy user in the home, and quite rightly, previous measures and incarnation of regs have mainly been focused on building fabric, insulation, and getting the heat source more efficient, so more efficient boilers, etc. And that's done a really, really good job in getting the space heating demand in new build homes down to a significant amount. But obviously, people's showering habits don't necessarily change, and in fact, probably people in newer homes tend to shower more than maybe people in older homes where they may just have a single bath with a shower over or something like that. So showering and certainly hot water use for showering really hasn't necessarily changed because you're in a more efficient home, and if anything is probably becoming more prevalent. So we're looking here at just a sort of an example of a energy mix from a home probably 15, 20 years old. And generally it's attributed that of the hot water generation, about 50% in new build in houses will be hot water use for showering. That can go up to anywhere up to sort of 70 or 80% in apartments, so generally more in apartments. And as I mentioned, about 85 to 90% of that heat energy from the shower goes down the drain. So lots of wasted heat energy and lots of heat locked up in that waste to use. So when we look at this as a kind of how much waste is there in new build homes for showering without wastewater heat recovery, if we look at that same sort of energy profile, about 2/3 for space heating and 23% for hot water, if 50% is showering and 85% is going down the drain, it's around about 10% that's potentially going down the drain, 10% of the home's energy budget going down the drain as waste. So it really is quite important. So, sort of about 44% of generated hot water could be lost through shower waste. And then when we look at that in the direction of travel that building regs are going, certainly with, to take it to the end degree with passive house, where you could be at sort of 10 or 15% space heating versus everything else being hot water, the percentage impact of wastewater heat recovery becomes more significant. So we're looking here at a kind of energy profile for a standard Part L 2021 home. So the space heating demand is lower, but by contrast, the hot water demand is higher in relative terms. And so therefore there's potentially more energy going down the drain and more that can be recaptured with wastewater heat recovery. And this does seem to be being picked up finally by regulation. So the new regs where we are now, Part L 2021, and also Future Home Standard, really have acknowledged that hot water, and in particular wastewater heat recovery or waste through showering, is important. And so it's been treated much more significantly now, I think is where we are. So just a quick overview on the direction of travel. So the Future Home Standard, which I'm sure you've probably heard of, the headline is that no gas boilers in new homes from 2025. So the reason for this is the idea is to move all new homes built from 2025 onwards to all electric heating. And the reason for that is not only to reduce the overall CO2 emissions of new homes as built, but also so that as the UK grid decarbonises, more and more renewables come online, what will happen is that those homes that are built from 2025 onwards, without any retrofit work needed, will naturally become zero carbon as the grid decarbonises. So that's the ethos behind Future Home Standard 2025. The issue at this point is that the demand for heating and hot water in residential far outweighs the grid capacity of where we are right now. So this is a nice little graphic that shows that. So what we really need to do, and certainly the way that regulation is driving, is to reduce the energy demand for new homes significantly, and certainly, obviously, that will also fall in for retrofitting existing homes, which is a different hornet's nest. But for new build homes, the regulation is driving demand reduction. So I won't go too much into the numbers there, but the takeaway here is that wastewater heat recovery is a great driver for that demand reduction in hot water use. Really, really significant. So the regulations are picking up on that, and So as I said, the Future Home Standard needs to go to all electric, but in the interim we have Part L 2021, which is the regulations where we are in transition at the moment. And that transition period finishes in June this year. So June 2023, 5 months now. And from that point, all new homes built in England will need to be built to Part L 2021 regulations. Those regulations have a new notional dwelling, which is the BRE's most cost-effective recipe for compliance, and in that recipe for compliance this is the first time they've included wastewater heat recovery. So again, confirmation that ethos of reducing hot water demand through waste is really quite prevalent. So just a kind of quick overview on the notional dwelling. The expectation on notional dwelling is that gas boilers will still be prevalent in UK homes, mainly because the infrastructure and the supply chain for air source heat pumps currently in the UK, which are going to be the main all-electric heating system, aren't quite mature enough to cope with a big transition at the moment. And as we're showing, the grid isn't there either at the moment. So the expectation is gas boilers to be used, but lower temperature heating emitters, so bigger radiators and a kind of 55-degree flow and return temp. PV to sort of dominate as well, so still PV on roofs is going to give that renewable energy boost, but then wastewater heat recovery and potentially other technologies, maybe flue gas heat recovery along those lines, maybe heat controls and things like that. So what we're hearing from developers, certainly the bigger developers that we're working with, is that 80 to 90% of those are still going to be producing homes with gas boilers under new regulation. That, as I said, is mainly because there is currently the UK market for air source heat pumps, which is likely to be the dominant technology from 2025 onwards, is still in its maturing phase. So the cost for air source is still higher than gas boilers, and the supply chain isn't quite there, the installation infrastructure isn't quite there yet. It's developing at a pace, so it will get there, I think, or certainly will progress a lot better, a good pace for 2025. But it's also probably worth mentioning at this point, as a demand reduction technology, wastewater heat recovery works equally well with air source heat pumps. It does exactly the same job. It reduces the amount of energy required to produce hot water. It reduces the amount of hot water required per shower, and showering is still that biggest part of the hot water demand. So wastewater heat recovery with air source heat pumps really does a good job of smoothing out the seasonality and the day-to-day peaks and troughs that you get with demand through heating and hot water on air source heat pumps. So just kind of just to cover the costs really, or at least where BRE see the costs for a gas boiler solution with wastewater heat recovery and PV versus an air source heat pump solution, and that's essentially that the cost for gas is going to be cheaper, or for a gas boiler based system will be cheaper, and that's where realistically we're seeing that with the bigger developers at the moment, is that it's a more cost effective option for wastewater heat recovery, PV and gas boiler. So we're working with a number of developers at the moment, so certainly some that we've signed supply agreements with, and then others that we're targeting. Recoup are geared up very much to work with the larger volume developers, so we're engaged with probably most of the top 20 at the moment at various stages. But I think this just kind of shows that it really is being taken quite seriously by the bigger developers as well, and hopefully the case study at the end, if we get time, will kind of bear that out as well. I'll whiz through this part very quickly because I've gone over most of it, but obviously the kind of wastewater heat recovery allows for known and available technologies to be used right now. It's not just us saying this, there's a number of think tanks, but the Future Homes Hub has done some fantastic work in identifying different routes to new build compliance and upgrading existing homes, different house types, semi-detached, detached, terraces, all with either timber frame or masonry builds, how you can upgrade them to meet new regs, and almost exclusively across the board they see wastewater heat recovery as being part of that mix. So it's really nice to see industry looking at this in the same way that we have been for these years as well. Easier infrastructure transition, so obviously most sites at the moment will be gas based. If you have large sites that are looking to transition onto new regs, it's going to be very difficult to put electric through those for an all electric solution, so it makes sense in terms of a transition infrastructure. And it's also worth mentioning that whilst we expect the wastewater heat recovery use across the industry to really grow exponentially because of these new regs, Recoup have a fully scaled growth plan, so we're ready and available, able to maintain our market share here, which is UK market leading. Here we go. So JB, or Craig, any questions at this point?
There's no further questions in the chat.
Thank you. Sorry,
it might just be worth mentioning that the recording of this webinar is available for people if they need to shoot off wherever. So if they give us their contact details, then we can send them a copy of this after the webinar's finished.
Great stuff, thank you. I have all the contact details. I'll be following up afterwards. So yeah, the recording will be available. Thank you. So just a quick look at designing in wastewater heat recovery. The key message here is it's relatively simple in most cases. And if you're coming across house types which look more problematic, we have a technical team here. The guys in the background, probably 80–90% of their working week is looking at house types with developers, assisting, ensuring that the most cost-effective systems are used. So feel free to lean on us as much as you need. But essentially, in most cases, a single wastewater heat recovery unit installed as System A to the master ensuite is going to give the biggest impact in SAP, and certainly probably the most cost-effective option for you. The sweet spot certainly is for wastewater heat recovery apartments, 2 and 3 bedroom homes with probably 1 or 2 showers. It really does have a very big impact in your SAP score. But obviously for bigger homes where maybe there's more showers, as I've said, primary wastewater heat recovery, so primary pipe hex installed as System A, any secondary showers, pipe hex installed as System B, or potentially an easy fit if you shower over bath, but usually the hex is going to still work in most house types. And considering wastewater heat recovery early on, certainly if you engage us with us early on, we can advise on sort of tweaks and things that we know to kind of make sure you get the best out of wastewater heat recovery, or certainly the least cost for wastewater heat recovery. So for instance, the obvious choice would be back-to-back bathrooms where you can run the shower or maybe shower over bath into a single pipe, and that will maximise the benefit but also reduce the amount of cost and installation cost as well. And as I said, we're here to support. So I'm just going to whiz through a kind of a designing case study which then shows some impact in SAP. So this is a pretty standard 3-bed, 2-bathroom scenario, thermostatic mixer shower in the ensuite, and just a bath in this case on the family bathroom. However, if there was a thermostatic mixer shower, we could put wastewater heat recovery on that as well. So what we're looking at is the most cost effective, as we said, is going to be pipe hex installed as System A to the master ensuite. If you do send through floor plans to us, generally we'll come back to you with a tabulated list of options. Obviously very simple in this case, but for larger houses there might be more options. But whenever you send something to us, we'll come back with specification notes, so you understand as a specifier or a developer why we're suggesting what we're suggesting. Design and installation notes, so these can be tagged to the drawings or into your design packs, so that the installers and anyone further down the line understand what's been installed and where and why. But also for the SAP assessors in the room, we'll supply with the PCDB numbers, so save you searching through reams and reams and reams of wastewater heat recovery variants. You can just plug this straight into SAP and it will come out for you. So we'll support you in as much as we can there. I think we've got a few SAP assessors on today, so I'll just very briefly, obviously SAP 10.2 has been released now. It's not been without its teething problems, I think it'll be fair to say, but the wastewater heat recovery element, and I think probably 90% of it is working pretty well now. It's an online system, which has been the first time, so it does dynamically change its look depending on how you're looking at it, which has caused a few problems. So what we'll show here is if you are looking at designing wastewater heat recovery you go to section 28, which is the water heating section, and you will simply check if it's one wastewater heat recovery unit, check as we're showing here for checkbox for an instantaneous wastewater heat recovery unit. At that point you can then specify the wastewater heat recovery product and installation method, or just pop in that PCDB number as we said, and that will populate it for you. You then go to the bottom and add in the number of baths, so how many baths are in the property. So in our example that would be checked as 1. And then what you do, and this is the bit that people are often missing, because sometimes this little plus box is down at the bottom and you need to scroll down to it. You need to connect the wastewater heat recovery that you've just specified to the shower it's going to connect to, and this is the point that does that. So you click that box, it comes up with a pop-up. You can then put in your description, so in this case we'd say ensuite shower 1 or something along those lines, master ensuite. You then check that box there, and you can add in the shower flow rate and which wastewater heat recovery unit it's connected to, and then save that, and it will then output the SAP score essentially. So it is relatively simple, but if you do have any issues, we've got how-to guides, we've got knowledge base, we've got videos on how to do this, and Craig in the background can easily just jump on Teams and run through with you and share screen and things. So if you're having issues, please feel free to come to us. So just to show that impact then on that 3-bed home modelled under current SAP, this was actually on the 10.1, so it might have improved slightly on 10.2 now. But as you can see, on this 3-bedroom terrace with wastewater heat recovery installed to master ensuite system A, we're getting a primary energy reduction. So this is a reduction on the home's energy use by 10.7%, which really is quite phenomenal, but also ties in quite nicely to the examples we were showing at the beginning there. And then in terms of a CO2 reduction, sorry, my screen's a bit blurry, 11.1%. So yeah, really quite significant, and that will obviously reflect in the SAP score. So really quite significant there. Often that's enough for new build developers. I mean, the reality of wastewater heat recovery is high SAP score for a low installed cost, and that's where the value is for most developers. However, for larger projects, for non-resi projects, or for retrofitting, we can give you as much granularity as you need. All of our products are third-party tested by Kiwa, which are an international test house. That data is the data that's taken by BRE to use in the SAP and the SBEM database. So we have all of that accessible here. We can plug in all the different permutations from whatever project you might be working on, hotels, new build, a leisure centre, for instance, and we can output kilowatt savings, percentage savings, CO2, etc., etc. So we can really get as granular as you need, and certainly if you're modelling in DSM or SBEM, all this can be added in as supportive evidence for you. I'll just draw your attention here. So this is, again, that 3-bedroom home. We're looking at around about 164 kilograms of CO2 saved per year on gas. And if we look at that against an air source heat pump, we'd expect around about 131 kilograms of CO2 against air source. I'm going to ask you to hold that thought, because when we look at the embodied carbon which has been measured for these products, so this is the TM65, which is the CIBSE standard for embodied carbon measuring, which we worked with CIBSE to help develop by giving them some data on our product. So we got an early calculation on our embodied carbon for the pipe hex product, which you can see at the bottom there is 59.63 kilograms per product. I'll whiz through this because we're running quite a bit late, but as you can see, when you compare the amount of embodied carbon that goes into producing the product versus the amount of carbon that the product can save operationally per year just in a 3-bedroom home here, it really is very insignificant. And then when you look at that across the lifetime of the operational savings on the product, it really does bear into insignificance. So it really is a very good product if you're looking at embodied carbon, and certainly SAP 11 from 2025 onwards is going to have an embodied carbon element. So it's certainly, if it's not something you're looking at now, something to bear in mind for going forwards. Right, I can see we've probably got about 10 minutes, so I'm going to very quickly whiz through this one. This is just an apartment case study. As I said, and as you probably guessed by now, if you've got showers over baths, the Easy Fit installed as System A or B is going to give you probably the biggest impact there, certainly the most cost-effective impact. If you have showers, so ensuite showers, you then have the option of the Pipex Active in apartments, and again, this will give a very big impact. Case study. So we've been installed with UK developers for years now, so we've got tens of thousands of products in the market, but a more forward-looking case study. This is the Barratt Z House, which you've probably seen in the marketing and in the trade press recently, because it's got a lot of eyes on it, and also the Energy House 2, which is where they've got essentially a similar house in a completely hermetically sealed lab, which they can control, make it snow, make it sunshine from -40 down to +40. So they're looking at how these homes perform under more extreme weather conditions. But the Z House was a concept for Barratt using an existing 3-bed detached floor plan. And then what they've done, they've filled that with around about 40 off-the-shelf, available now, technologies for energy efficiency, for sustainability and for biodiversity, and essentially produce their blueprint for their standard home, which is net zero ready right now. And this is being developed as a model for a cost-effective, usable model for now for Barratt, which they intend, I think, to take forwards from 2030 onwards. But that may well come forwards because they're doing a lot of research on it at the moment. So as you'd expect, wastewater heat recovery has been included in this. So this was that example that I showed earlier. As much press as the Z House gets, we don't get as much press for the wastewater heat recovery unit simply because initially you couldn't see it. So what we did, we've put some stickers in there now so people know that we're there. But as you can see here, that's the wastewater heat recovery installed into the Barratt Z House. What's again notable of this, it's a highly efficient fabric, but the hot water use is still being monitored here. Air source heat pump generated hot water with a Kelder low flow shower on the ensuite, down to I think about 5.5 litres per minute shower flow rate, and then a standard flow restrictor on the thermostatic mixer shower over bath on this one, and the wastewater heat recovery is working perfectly well. So we really are, showing here that wastewater heat recovery is a future-proof technology for homes going forwards. Again, just very simple to design in. I'm going to hold that there really just to say we have as much resource as you need online, installation videos, YouTube videos, even these CPDs are going on YouTube now, so feel free to go back through. Online technical presentations, obviously, as I said, that we're going to be putting a non-resi presentation forwards, learning portals, installation, certification routes as well. And also this studio that we're sat in. So if you're a developer, if you're a merchant and you want dedicated resource, we can put that together for you as well. So just finally, before we wrap up, just to say thanks very much everybody for your attention today. In lieu of what would usually be a lunch and learn, would go out to you, would give you a sandwich and sit and give you an hour's worth of CPD, we now donate 25 trees. So just to say thanks for joining us online. It helps us save carbon. It really does maximise our resource, and to help you on your sustainability journey, which I'm sure a lot of you are on already, we'll donate 25 trees for every CPD certificate that we issue. So I'll send you the link for that following. Just a couple of details. It will give you a CPD certificate, and then it will donate the trees for you as well. So thanks very much everybody, and I'll just switch over to questions.
We've got a couple of questions, Ellis.
Sure.
Maddie's asked about how do you approach with design and install when using modular bathroom pods manufactured off-site?
In exactly the same way, realistically. I mean, there's obviously, because there's so if the wastewater heat recovery can be installed within the pod, then realistically there's absolutely no different in practice or in principle. If, for instance, wastewater heat recovery or the pods are being installed, let's say in a hotel or a student accommodation build, normally the wastewater heat recovery, and most often it will be the vertical pipe, will be located in the service risers. So obviously with that kind of blueprint, it's generally back-to-back shower rooms which are replicated up around a central service riser. That works very, very well, and we've got any number of hotels and student accommodation designs where that's shown. In fact, one of the longest installed one is the London Standard Hotel on King's Cross. So just across from King's Cross Station, the old Camden Town Hall building has been redeveloped into London Standard. That has, I think, 70 wastewater heat recovery pipes, 2-to-1. Against 150 podded shower bathrooms. So we've got that as a case study on the website. So yeah, that's realistically can be designed in a similar way. If you've got a project, give us a shout. We'll run through it on Teams with you. We can look over your drawings and things. Anything else, Craig?
One other question. Sorry, one other question from Howard. Asking how quickly are you likely to get back your capital cost from a reduction on heating load in a bigger project like a hotel?
Good question again. So the heat recovery efficiency and all those other things, the measured parts are very much fixed. And as we said, like the heat recovery efficiency will adjust with shower flow rate. So that's a variable. The biggest variable is always how much use does it get and how long are people staying in the showers. That will change. So on a project by project basis, we can take any assumptions that you have and plug them into our calculator. Also, if, for instance, you're designing a hotel or a student accommodation project and you have a hot water calculation for the amount of hot water that's going to be used by showers or overall, we can also plug those straight into our calculator. And then rather than look at occupancy rates, we just use the hot water from your existing model. So it all ties in really well. So it's a little bit more complicated than the calculator that I showed. Not too much more, in fairness, but it just ramps up, more bathrooms and more use. So, but I guess to ballpark it, which is certainly on leisure facilities, we see anywhere between sort of 1.5 and 5 years often on ROI. On hotels and student accommodation, again, we can calculate it. It generally is longer because you might only have a single use per day maybe, but obviously the hot water use of that building is a big part, and you've still got to get through compliance. So it's not so much the ROI in terms of usage, it's more a question of, if you don't use wastewater heat recovery, how much more do you need to spend on getting compliance? And that generally is a lot more, because certainly with space heating measures, insulation, facades and things, it's a bit of a diminishing returns. You can only throw so much at insulation before the cost outweighs the benefit. So moving on to hot water and reducing that energy through the hot water side gives you a bigger, a quick win quicker, essentially. Hopefully that kind of answers without giving you a direct answer, but we can give direct answers based on projects. Anything else? Kind of throw it open to the floor if anybody has questions.
There was one just question from John about the clearance required under a shower tray, so the size of shower tray required. Good. I think the easy fit is about 95 height and about 1400 tray typically. Yeah,
so designed to fit under a standard size bath, sort of 14 to 17, 1800, and certainly under a shower tray 1400 onwards. The unit itself has adjustable legs to give it some fall on one side or the other. As a minimum there, the unit is 65mm, around about 40mm extra, or 30 to 40 to give it full. So anywhere between 95 and 105 millimeters would be standard clearance. Obviously, if your pipe runs are then running further off, you may need to adjust that slightly. But in most cases, the SVP or the drain is very localized to the bath. So in most cases, 105mm would be pretty standard. We have a demonstration unit here, so we can kind of show you how that works on a direct call. Good. Okay, well, if that's it, I think we've pretty much just hit time, which is really good. Okay, thanks very much, everybody. I will hold on. Let's go on, one more. Go on.
One last question just popped through, which is quite a good one, which is how many showers can you run into a single pipe? Thanks.
Yeah, good question. It will depend on the total flow rate of the showers and the installation method. Total flow rate for the vertical pipe as System A is 16 litres per minute. So if we were looking to install a single pipe, for instance, connected to a shower over bath and an ensuite, the total flow rate of System A would need to be 16 litres per minute, so 2 8 litre per minute showers. But if that was installed as System B or System C, slightly less efficiency, but it gives us more headroom, so up to 22 to 24 litres, so 2 11 litre per minute showers, which is a pretty high flow rate for new build these days, in all honesty. So, two showers at 9 litres per minute would be common. Certainly that can be coped with a single unit. On more commercial systems, so with the drains on banks of showers, certainly 2 showers into 1 drain is very common. But if you've got banks of showers, 3 showers into 1 has been done previously. It will depend on the flow rate and how far apart they are in terms of how our pipe work. But again, we can advise on that. But normally 2 in domestic settings and 2 or possibly 3 in non-residential communal showering environments. Great. Right. In that case, then I will hold there. I'll say thanks very much, everybody, and switch over to the final, just the holding slide here. But I will stay online if anybody does have any direct questions or wants to just have a chat. And obviously, we'll come back to you with the follow-up email, a link to the recording and some resource links as well. But thanks very much, everybody. It's been a good presentation. Thank you.